Following on from the previous video, we got to this stage here where this thing here is 3, because you can always visualize 72 as root 9 times root 8, and then you've got your root 8 here, so these two cancel out. This here is 3. Well, this whole thing here becomes this. So now visualize this as visualize this as secant cube. Okay, secant cubes of the angle. So this thing here is secant cube of the angle. So it will be this thing here. Okay, so now it's just a matter of integrating this thing here. So integrating it. Remember, we've done this in the past. We spent a long time trying to integrate this. When you integrate this, it will give you this whole thing here, and we've spent a long time on this. So if you don't understand this, then track back to one of the early videos. But we have done this. So when you integrate this, it will then give you this thing here. But the problem is we've got half of the angle here. We don't want the whole angle. We want half of the angle. So currently, as it stands, if you differentiate this whole thing here, it will give you this. But we don't want the whole angle. We want half of the angle. So what we should do is make this to be our initial guess. So make this to be our initial guess. So when you come to differentiate this, when you come to differentiate this whole thing here, when you come to differentiate it, it will give you this, which is quite good here because we've got this. But then when you come to differentiate this, it will give you this thing here. But then you've got to times the derivative of the bubble itself. You've got to times this half here. But then we don't want this half here. So we need to make the adjustment. We need to times everything here by 2. That will then negate this. So that's why you've got this 2 here. So hang on. It's a bit like this here. If you have sine the bubble here, if you differentiate it, and it gives you cos theta, cos the bubble, but then you only want theta over 2, then you should make this to be your initial guess. But then when you differentiate this, it will give you this thing here. But you don't want this half, so you would make the adjustment. You would make the 2 here. Now, when you differentiate it, it will give you this thing here. So we need to make the adjustment. That's why this 2 here. That's why we've got this 2 here. Well, think about it. Integrate this whole thing here, and then it will give you this. Okay, think about it. It will give you that, and then now let me think. Now you've got half here, you've got a half here, so these will cancel out, giving you this thing here. So now we can get rid of the modulus here, because in the domain from 0 to pi over 2, secant of well, this thing here will be in between 0 and pi over 4. But the thing is, if you look at the secant graph here, between 0 and pi over 2, it's always positive. So we don't really need the modulus sign. And then if you look at the tan graph, in the domain 0 to pi over 2, in the domain from 0 to pi over 2, tan, which is this thing here, tan is always positive anyway. So because this block here will always be positive in between 0 and here, and this block here is also positive in between 0 and here, we can ignore the modulus and just use brackets. Okay, so this thing here will then become this. So basically, we just remove the modulus sign, so we can just ignore it. Okay, so now we can put this into here, So when you have pi over 2 divided by 2, that will then give you secant pi over 4. But I'm going to visualize secant as 1 over cos pi over 4. So visualize this block here. Visualize this block here as this, and then this block here as this, because you put this into here. So this block here will then become this, and then blah blah. This put it into here, it becomes this, and so on. And then put 0 into here. That will then give you this. Put 0 into this. This will then become this. Put 0 into here. This thing here will become this. Put 0 into here. Then this will become this. So when you look at this, cos, well, pi over 4, pi over 4 from here to here is pi over 2. Pi over 4 is like 45 degrees. So when you think about 45 degrees, think about that famous triangle where you have 1, 1. This has, the hypotenuse has no choice but to be root 2. So cos 45 degrees is really 1 over root 2. So this thing here is 1 over root 2. But then you've got 1 divided by that. So this block here becomes root 2. So it becomes root 2. And tan 45, think of this famous triangle where you have 1, 1. This is 45. Well, tan is this thing here. So tan is 1 over 1. This block here is 1. And then use the same argument. This whole thing here will then become this thing here. Okay, and then tidy this whole thing up. It will then become this. So this here is your final answer. Okay.